Hey guys, it's me, Miss Yealy. I'm here just making a video for your 11.05 notes. We're gonna start by doing a bunch of word problems. So it's kind of the first time this year that we've actually been doing applications on like when you would actually use this in real life. So we're gonna be talking about exponential growth, decay, and half-life. We're also going to be talking about compound interest today. You will need a calculator for this. Easiest calculator to use is obviously the TI-36X Pro, but you could do it on your phone calculator or anything. Obviously, since you're at home, you can use your notes, you can use your calculator on anything that we give you. So we're back to using calculators. We haven't used calculators in a while, but we will be using them here. So for this part of the unit, we're going to do 11.05 and 11.06 using these same formulas. And then the next week after 11.06, we're going to be doing a project where you're actually going to put this into kind of budgeting for your future, how student loans work and car loans. So this is actually real life math and real world applications. So we have three different formulas on the front. There's some more formulas on the back or the next page of notes. But before we get into doing anything with the formulas, let's talk about what each variable means. So we have the three formulas. We have growth, decay, and half-life. Some of you guys might have used half-life in a science class, maybe chemistry or physical science. I know that they use half-life, and it might be a little different. Maybe the variables might be like slightly different than you've seen, but basically it's the same thing. So the only difference between growth and decay is growth, you're going to be adding the rate, and decay, you're going to be subtracting it. Obviously, grow is getting bigger, it's increasing, you're adding. Decay, you would be subtracting, getting smaller. The exponent part is t, right here, raised to a power, and this is also an exponent too, t over h for our half-life formula. All right, so where each letter means something, so the A is the ending amount. So A is your ending amount. That's the amount you're going to have at the end. And I think once we start actually plugging these into specific problems, it's going to make a little bit more sense. But I want to have them like list out what each variable is first. P is your initial or your starting amount. So that's your initial. So that's what you're starting with. And when you read through the problems, it's going to be kind of important to read carefully and look at the words and what the words are telling you each number means. The T is for time. And that could be hours, months, days, years. It's different. And it will say in the problem as well. H is for half-life. And that will be given in the problem. So when it's a half-life problem, it will say the half-life of this is. So it's going to be a time amount. It is a value of time, but it will literally say the half-life is this. So there'll be two different things for half-life. There'll be the time and the half-life, and there'll be two separate numbers for those. And then R is the rate. It'll be given as a percent, but we need to convert it to a decimal. And I know this sounds like kind of stupid. When you convert from a percent to a decimal, we're moving the decimal place over, but I pretty much always just divide it by 100 because then I know I'm right. Sometimes when you guys think you're moving it over 2, like you end up only moving it over 1, or you just don't do it right. So every time if it's given as a percent and you're converting it to a decimal, dividing it by 100 is probably the easiest way to like not make any errors. So these are what each thing means. So A is your ending amount, P is your starting amount, T is time, H is half-life, and R is your rate. And again, you have to use that as a decimal. You can't plug it into the formula as the percent, or your number is going to end up being gigantic. So, all right, so we're going to start by doing number one. Ellie wants to attend a state university where the annual cost of tuition was $4,300 in 2000. Each year, the tuition has risen 4%. Find the cost of Ellie's tuition in 2020. All right, so the first thing that I want to do is I want to figure out which formula I'm going to use. I'm going to either use growth, decay, or half-life. And there's a word in the problem that usually tells you this. And in this problem, the word is risen. Risen essentially means that it is growing. So risen, growing 4%. So you think about, is it getting bigger? Is it getting smaller? The cost of tuition, unfortunately, has been going up significantly, so it is growing. All right, so then I'm going to figure out what each variable is, and one of these is going to be a question mark. Essentially, we have to solve for something. So it says that her cost was $4,300. If it was $4,300, that's what we're starting with. In the initial year, it started at $4,300. In 2000, each year has risen 4%. That is our rate. It was 4%, and when I divide that by 100, I don't think I'm gonna fit it that way. When I divide it by 400, it's 0.04. 0.04. All right, and then we have to think about time. It didn't say the time is this. It didn't give it to us exactly. So we actually have to figure out what the time is. So it started in 2000 and it ended in 2020. If it started in 2000 and ended in 2020, the time is 20 years. 20 years have gone by, so it's 20 years. All right, so from this point, pretty easy, pretty simple. We're just gonna be plugging this into our growth formula. The growth formula is A equals P, 1 plus R raised to the T power. So essentially, I'm just plugging in what we know. We're gonna be solving for A. A is what we don't know. That's what we're trying to figure out. So A equals $4,300, 1 plus 0.04 raised to the 20. So basically what we're trying to figure out is what is her tuition in the year 2020? If it's grown 4% per year, what's her tuition gonna be now? And this is when I'm gonna plug this just straight into my calculator. 4,300, 1 plus 0.04, raise that to the 20th power. If you're doing this in your phone calculator, you're probably gonna have to take it one step at a time and just plug that into your calculator and then raise it to the power and then multiply it. Just remember, you have to use please excuse my dear Aunt Sally. If you're using a TI-36X Pro, then all you have to do is plug it straight in, hit enter, and my final answer is A equals 9,421.83. And I'm rounding to the nearest hundredth, 2 decimal places, because we're talking about money. This is an amount of money. This is what her current tuition costs. So that's what the tuition costs in the year 2020. If it started at $4,300, it's gonna end at $9,421.83. So again, to round, it was a 2. Look at the next one, it's a 9. You have to round up to get the 3. So just make sure you round appropriately. You can't just like stop and not write the next number, so the 9 rounds the 3 up. I know that sounds kind of stupid, but all right. The next problem, Charlie bought a new car for $34,000. The value of the car depreciated by 13% each year. So the car depreciated by 13% each year. Find the value of Charlie's car after 3 years. All right, so the first thing I need to know is what formula am I going to use? There's a word in the problem that tells us that. The word in this problem is depreciated. And this, unfortunately, is something that actually does happen. As soon as you buy a car, it is no longer worth what you bought it for. It immediately goes down in value. So from the day that you buy it, it immediately starts going down in value. So the depreciated means we're going to use decay. The value of the car is getting smaller. The value is going down. All right, so we're gonna be using our decay formula, which is A equals P 1 minus r raised to the t. And we've got to figure out what we are given in the problem. So he bought the car. Initially, his starting value is $34,000. So when he bought it, it starts out at $34,000. It depreciates by 13%. That 13% is our rate. And remember, I have to divide that by 100 or move the decimal place over 2, which is 0.13. And then time is actually just given in the problem as 3 years. So I'm just going to be plugging in each value. A equals 34,000. Whoop, forgot an O or a 0. 34,000. 1 minus 0.13 raised to the third power. So then I'm just going to be plugging that straight into my calculator. So I have 34,000, 1 minus 0.13 raised to the third. So after 3 years, his $34,000 car is now only worth $22,389.10 and 10 cents. So it was worth $34,000. That's what he bought it for, but now it's only worth $22,389. So it's going down significantly. All right, the half-life of iodine 131 is about 8 days. So this is a half-life problem. The half-life, the only time you would ever use the half-life formula is if the problem says the half-life of this is. It has to give you some sort of half-life value. The initial sample is 50 grams. What is the amount of iodine 131 remaining after 12 days? So the half-life formula is what we'd be using. And typically with half-life, you're going to be using like substances. I think we talk about like different medicines in your body having a half-life. So essentially half-life is decay, and it's decaying by half. So it's just a specific decay formula. So our half-life formula is A equals P times 1/2 raised to the t over h. Remember, that is an exponent. Even if it like looks bigger, it's still being raised to a power. All right, so it says the half-life is 8 days. That's our h value. The half-life is that. That's what it's telling us the half-life value is. The initial sample, initial means that's what we're starting with, 50. And the t is 12 days. So this is a little bit confusing because it's like there are two things that say days and you're like, well, that's two time values, but one is the half-life and one is the time. And again, A is what we are solving for. So I'm just going to be plugging this into my formula. A equals P, which is 50. 50 times 1/2 raised to the 12 over 8. T is over H. So A is 50, or A equals 50 times 1/2. You can use your fraction button. You could also use just 0.5 there, 1/2, 0.5, they're the same thing. Raised to, again, fraction bar 12 over 8. This would be a little tricky to use in your phone calculator, but again, just please excuse my dear Aunt Sally, start with the exponent, then raise it to the power, then do the multiplication. So don't multiply 50 times 1/2 first. You've got to do exponents before you do multiplication. And when I get my answer, A equals 17.68. I'm just going to round it to 2 decimal places because a lot of them will be dealing with money, so just go ahead and round it to 2 decimal places. And this is, we're talking about grams. And this actually makes sense. So if you think about it, after 8 days, it would have been cut in half. So after 8 days, it's cut in half to 25. And since 12 is more than 8 days, it's less than half left. So every 8 days, it's being cut in half. So after 8 days, it's 25. And then after 8 more, so 16 days, it would be 12.5. So each 8 days, it's being cut in half. And this is between 8 and 16, essentially. I know that's kind of confusing, but All right, so John has inherited land from his grandparents that was purchased in 1970. The value of the land has increased. That tells us what formula. It's increasing, that's growth. Approximately 2% per year. The land is now worth $120,000. What was the original amount? So this problem is slightly different, but we're going to be using the same formula. So this is growth because it says it's increasing. Usually the value of land, hopefully, goes up. The value of like houses and land and things like that go up. Cars are unfortunately depreciating. So this is our growth. A equals P1 plus R raised to the T. All right, so this I said was different. And the reason it's different is because it says it is now worth. The current value of the house is $120,000. So that is our A value. That is what it's currently worth at the end of those years that have gone by. So that's $120,000. That's what our A value is. It's 2%, so our rate is 2%. Dividing by 100 is 0.02. The time, it was purchased in 1970. We're going to assume that we're talking about right now. It's 2020, so 1970 to 2020 is 50 years. And then P is what's missing. Remember, you're always going to have one thing that you're going to be solving for. So P is what we're solving for. So A is 120,000 equals P, that's what we're going to be solving for, 1 plus 0.02 raised to the 50. All right, so we are solving for P, and that is on this side of the equation. So we're essentially needing to get P by itself. P is being multiplied by all of this. So since P is being multiplied by that entire parentheses, in order to get it by itself, I'm going to divide it. And I'm going to do this all in one step so that I don't have to worry about rounding it multiple times. Because the more you round it, the more kind of like off it gets. It won't be an exact answer. So I always want you to just round at the end rather than trying to round while you're doing it. So essentially, I'm dividing by this to get P by itself. That will cancel out on this side, and then we can just plug that straight into our calculator to get what P is. So when I plug that in my calculator, I just use my fraction bar. 120,000, got that, times 1 plus 0.02 raised to the 50. And again, just put it in with your calculator. If you're doing it with your phone calculator, I know that's probably a little bit tricky, but just do it one step at a time. Try not to round as much as possible. And then we get P is equal to $44,583.35. So essentially what this means is they bought the land for $44,000, and now that it's been 50 years later, it's worth $120,000. So they bought it for $44,000, and now it's worth $120,000. It grew in value. The value at the end should be more than what it started at. All right, Sophie inherited a diamond ring that was purchased 20 years ago for $500. The value of the ring increased by 8% each year. What is the value of Sophie's ring today? All right, so her value is increasing. That means it's growth. It was purchased originally for $500. So that's our P value. It's increased by 8%. 8% as a decimal is 0.08. Remember, you're dividing by 100 to get that, or just moving it over 2. And how much is it worth today? So it was purchased 20 years ago. So that is our time. So unlike the last one, this one you can just plug into the growth formula exactly as is. So when you're solving for your A value, you do have to divide. So we have A equals 500 1 plus, the rate was 8%, raised to the 20th. Plug it into my calculator. 500, 1 plus 0.08, raised to the 20th. Whoa, that's not an exponent. Raised to the 20th power. So make sure you use that exponent button. If you don't, then the answer obviously will not be right. So her ring right now is worth $2,330.48. So it started 20 years ago at $500 and it has increased to $2,330. All right, a drug trial trial determines that it takes 3 hours for the human body to eliminate half the drug from its system. If 200 milligrams of the drug are administered, then how many will remain after 7 hours? So it says half-life. It doesn't say half-life, but it says half. So I am going to say this is half-life. This is a half-life problem. It takes 3 hours for half of it to be eliminated. So 3 hours would be our half-life. If you start with 200, how many will remain after 7 hours? And we'll be solving for our A, the amount at the end. So A equals P times 1/2 T over H. So plugging our values in, A equals 200, 1/2, T is 7 over 3. So after 3 hours, you would assume that there would be 100. After 6 hours, you would assume that there would be 50. I'm just cutting it in half each time. After 7 hours, let's see how much will be left. So 1/2 raised to the fraction bar again, 7 over 3. And I'm assuming it's going to be under 50, because if you cut it in half twice, you would have 50. It should be slightly less than that. So A will be 39.69 milligrams. And you don't have to be able to do it in your head. Obviously the calculator is giving you the answer that you need. I'm just kind of trying to give you a little bit higher understanding of what is actually happening with half-life. All right, so that is growth, decay, and half-life. On the next page, we're going to be talking about our compound interest. And this is how banks and loans and everything calculate your interest values. So compound interest, we have 2 formulas. We have compounded n times. We'll talk about what n means in a second. And then we have compounded continuously. If it says compounded continuously, it'll say that in the problem. You're going to use our A equals PERT. The A and the P mean the same thing that they did on the other. The E, remember E is from our chart. It's 2.713, but use the E button in your calculator. I'm pretty positive. I can't really check my phone right now because it's being used to make the video, but I'm pretty sure your calculator on your phone has the E also. If you turn it on its side, you can see that E button, but we're going to use E in the calculator. It is a number, so it's not something that's given in the problem as a variable. So E is actually a number in the calculator. If you look at your compounded n times formula, you have a new variable, which is n. And n means different things based on what it says in the problem. N is the number of times it's compounded per year, the number of times it's compounded per year. So if it's compounded annually, that means it's compounded 1 time in that year. If it's compounded semi-annually, it's 2 times. That means it happens twice a year. Monthly would happen 12 times. And quarterly would happen 4 times. If it says daily, daily is 365. Weekly would be 52. Just think about how many times that happens within the year. Most of the time, banks are going to be compounding things monthly. just because you get like monthly statements. So they're compounding it each month. You're earning interest in that bank every month. But it could be different depending on what bank or anything that you're looking at. So just know that. All right, so these are both growth. Typically when you put your money in a bank, your value grows over time. For the purpose of the problems, the interest rates that we're giving you are going to be higher than they are if they were actually like a bank giving you money. So don't look at this and be like, wow, that's a lot of interest. It's like harder to show. Typically, if you look at your like bank statement, if you guys have like a checking or a savings account, you're not really earning that much interest. Unfortunately, banks just don't give you that much interest in your account. So if you're ever curious, you can always look at typically your savings account and look at your interest that you get each month. And it's probably not very much at all. Probably like 1 or 2 cents, depending on how much you have. The more you have, the more interest that you're gonna make. Just know that also. So, all right, Jason received $500 cash in birthday gifts. He deposits into a savings account earning 2% interest. How much will Jason have when he graduates from college in 4 years if the interest is compounded blank? We're actually going to do this same problem 4 different times depending on when it's compounded. So these values will be the same each time, and then we're going to change the number of times it's compounded. Our A value is what the amount at the end. That's what we're going to be solving for. So A is what we're solving for. P is what we start with. He starts with $500. T is time. He's putting in the bank for 4 years. And we're assuming that when he puts this $500 in the bank, he's not going to touch it at all. Obviously, if he touches it, he uses it, that's going to change the amount that he has. We're assuming he puts it in the bank, he leaves it there for 4 full years without touching it at all. And we're going to see how much there is at the end. And then the rate is 2%. Just like on the other page, we're going to use that as a decimal, 0.02. All right. So if it's compounded annually, we know that that is once per year, and we're going to be using our compounded n times formula at the top. So A equals P 500, 1 plus the rate 0.02 over n is 1. And then we have T 4 times 1. T times, or n times T, obviously it doesn't matter which way you do it. So we're just gonna go ahead and put that into our calculator. We have 500, clear it out, 500, 1 plus fraction bar 0.02 over 1 raised to the 4 times 1. Again, forgot the exponent part. Exponent 4 times 1. Obviously the ones, guys, when you divide by 1 or multiply by 1, neither of those ones will do anything, but I'm going to use them or put them in my calculator now so that I'll show you a trick that you can use. 541 and 22 cents, sorry. So essentially, using this 2% interest, which is higher than most banks will give you, if he leaves his $500 in the bank for 4 years, he's going to gain $41.22. So over that 4 years of time, he's getting $41 for essentially doing nothing with that money other than leaving it in the bank. So if it's compounded quarterly, now our n value quarterly means it's happening 4 times per year. So we're going to use the same exact formula, but instead of those ones, we're using it 4 times per year. A equals 500, 1 plus 0.02 divided by 4. 4 times 4. And what's really cool about this calculator is instead of having to type that whole thing over, if I just use that button right here and scroll up and highlight where I typed it the first time, I can highlight it and then scroll over to just change those 1s to 4s rather than having to type it all over. Again, if you want to type it again, totally fine. It's just easier to scroll over. So when I do that, I get A is $541.54. So basically the same amount, just slightly higher when you're compounding it 4 times per year. So that means essentially interest is earned 4 times per year. So you're earning interest on your interest. So the more times you compound it, the more interest you're actually going to be making. So we would expect that our monthly, compounding it monthly will be slightly higher than it was when we compounded it quarterly. So monthly means it's happening 12 times per year, every month. A equals 500. 1 plus 0.02 rate over 12, 4 times 12. So basically nothing is changing except for now I'm compounding it 12 times per year. So I can scroll up, change those 4s to 12s, hit enter. $541.61. So again, it was slightly higher. In this case, it doesn't really matter. It's not making a huge difference. But if you had like millions in the bank, then it would be a significant amount. So again, $500 isn't really that significant. It's not making much of a difference between these 3. But if it was millions of dollars, then it would matter a lot more. And then the last one is if it's compounded continuously. So compounded continuously is our, I call it the PERT formula, P-E-R-T. A equals P-E raised to the R times T. P is 500. Remember, E is not a variable, it's a number that's in our calculator. 0.02 is the rate, and the time is 4 years. And I'll show you in the calculator where that E button is. So 500, the E button is the same as the pi button. So it's where the pi is. You just have to hit it twice to get E. So I hit it twice to get the E. And then I'm gonna raise that to 0.02 times 4. And that is that same $541, but slightly different change, 0.64. So if you compound it continuously is actually less than it was monthly. No, it's not. I just wrote this wrong. This should be 61 cents. Sorry. So I just obviously rounded that wrong. That was our monthly. The compounding continuously should be the biggest one. Again, it's compound. The more it's compounded, the more money you're going to be making. Typically, everything is going to be compounded monthly, but you never know. All right. Grace deposited $1,000 in her account, offering 2% interest compounded continuously. That's important because that tells you what formula to use. A equals PE raised to the R times T. 2% is our rate, which is 0.02. The time is 4 years, and she put $1,000 in the account. So she started with 1,000. We're gonna see how much she has at the end. So A equals 1,000. E raised to the 0.02 times 4. So we have 1,000. Using that E button, which is where pi is, I just have to hit it twice. Raised to the 0.02 times 4. A equals $1,083.29. So as you can see, the more money you have, the more money you're gonna make. All right, and last question, if Grace, how much money should Grace invest initially to have $20,000 in the account after 18 years at 2% interest? So how much money should she invest initially to have $20,000 at the end of 18 years? And I'm gonna star this one because this is a problem that's gonna be on the project. There's a couple other ones on the sheet that will also be, but this is one of the more challenging ones on the project because it's kind of that going backwards. So this you will see again. How much money will Grace how much money must she initially invest, to have $20,000 at the end. So she wants $20,000 at the end. How much does she initially have to put in the account? T is 18, and the rate is 2%, 0.02. So this time we're gonna be solving for P, and we saw one of these on the other sheet or the other page, but again, to solve for P, when you're solving for P, you have to divide. Hopefully you can see this, yeah. So when you solve for P, you're gonna have to divide. So A is 20,000. It's compounded, we're gonna assume it's compounded continuously again, because this is just part B. A equals PE raised to the RT, 20,000 times P, E raised to the R times 18. Again, if you're solving for P, you're gonna have to divide. So in this case, I wanna divide by everything that's not P. I'm gonna divide by E, 0.02 times 18. E raised to the 0.02 times 18. That will cancel all that out, and you'll be left with P by itself. And to do this in your calculator, essentially, I'm just gonna use the fraction bar, 20,000 divided by E, the E button. And actually there's an E button that's being raised to a power. You can use that also, or you can just use the E and then raise it to a power times 18. So if she wants to have 20,000 after 18 years, then she should have put in the bank $13,953.53. So if she wants 20,000 at the end, she needs to put in 13,000 originally. All right, so that is the end of the 11.05 notes. Your 11.05 practice will be due. You don't have to turn in the full notes page with the practice. We just want the practice page. Make sure you put your name on that practice page. So if you're turning in a picture of it, you need to put your name on the picture. Thanks for watching, and goodbye.